All right, as we continue our exam review, several things that we talked through yesterday, we didn't actually practice yesterday. Write this down in your papers if you would, please. 7m squared negative 3n and 2m squared positive n. We said yesterday if I want to multiply similar binomials, class, I should use FOIL, right? But we didn't actually practice FOIL. What does FOIL stand for, class? First, outer, inner, last. But remember, the outer and inner, if they're similar binomials, outer, inner will combine together. So when we multiply the first, what do we get, Michael?
14 and 4.
Good, because when we multiply like basis, class, we add the exponents. When we multiply the outer, Kendall,
7m squared n.
good, it's a 7m squared n. And then when I multiply the inner, Kendall,
Negative 6m squared n.
but I've got to combine the positive 7m squared n with the negative 6m squared n. If you want to write them down, you certainly could. I don't necessarily recommend it, but you can. We combine to get
Positive 1m squared n.
good. And we don't necessarily have to write the 1, but it's not a problem. First, outer, inner, Genesis, we now multiply the last together. What do we get? There we go. What if we wanted to multiply a 7m squared negative 3n by a 7m squared positive 3n? We could technically FOIL here, but there's a better way because, Audrey, this is a sum and difference. Sum and difference gives us? Class? Difference of squares. Sum and difference gives us a difference of squares. 3 things we need to do to multiply a sum and difference. Other one. What's the other one? Class helper. Square the first, square the last. Minus sign between them. Okay, so back to Audrey. You square the first. You square the last. And then, of course, we just put our minus sign between them. What if I had something like a 3ab cubed? I was multiplying by a 2a, positive 5b, negative 12. What would I have to do here, Brandon? Distribute to get?
6a squared b cubed, positive 15ab to the 4th, negative 36ab cubed.
There we go. Sign number letter 1, sign number letter twice, sign number letter 3 times. What if I just had something like a 5x cubed y to the 4th being multiplied by something like a 12xy squared? Well, that's just regular multiplication. Class, that's just what 3 things? Sign number letter. Yeah, what do I get when I sign number letter here, Genesis? There we go. Because the signs are the same, we get a positive. What if the signs have been different, class? You get a negative. Of course, if they were both negative, then they're still the same. We still get a positive. Converse of multiplication was factoring. So if we had something like this, m cubed negative 216. What special factoring case is this? Anyone? It's a difference of cubes. Or you could say difference of same odd powers. Either way, what do I get when I factor a difference or a sum of cubes? Binomial times, in this case, a trinomial. But one of the keys, remember, is to rewrite any numbers as cubes. So, Kendall, I might rewrite the 216 as 6 cubed. So it might help to say m cubed minus 6 cubed. Then we're going to factor that into binomial, trinomial. What's the binomial going to be, class? M minus 6. Now, the hard thing, I say hard, is getting the trinomial. I'm going to start with the m, but it's going to be m squared. Then m, then gone. The 6 begins by being gone, then 6 squared, or 36. What about the signs if I've got a negative right here? All positives. Can you factor this trinomial? No. Nope. Remember that trinomial from the binomial trinomial will not factor. What if I just had a trinomial like, for instance, a 6 squared negative 17x negative 10, something like this. We've seen a lot of these throughout the course of the year. What do I do with trinomials to factor them, Brandon? Backwards FOIL. And we start by splitting up the 6x squared, remember, class, into probably 3x and 2x, maybe 1x, 6x, I don't know, but let's just try 3 and 2. I look at my last sign, it's a negative. Alternate, one's positive, one's negative. Probably splitting up the 10. 2 and 5. Can't be 5 and 2, right? Because there wasn't anything common. Probably 2 and 5. Does the outer inner check? Okay. Well then, let's try 6 and 1. Because I can't flip the 3 and the 2, right? So let's try 6 and, well, I can't put 6 with 2 though, can I? Let's try 6 here and 1 here. Now let's try outer inner. Does that work? Thoughts? It can factor. Instead of maybe 1 and 6, though there's nothing wrong with trying 1 and 6. Let's go back to the 3 and 2, and let's try instead of 2 and 5, let's try 1 and 10. Now again, I'm not going to put the 10 with the 2 though. I put the 10 here and the 1 here. Does that work? Just switch the signs, right? The number's there, the sign's not. So remember, there's oftentimes trial and error involved in our backwards FOIL. Just stick with it till you get it. What if we had a 5x cubed negative 10x? What's the first thing I always check for when I factor, class? And what's common? 5x. And when I pull out the 5x, what am I left with, Audrey? And I should always look after the common factor saying, can I factor further, class? No, it looks like it'd be a difference of squares, but it's not. What about this? If I had an x squared, negative 12x, positive 36, what might I do here? Anyone? I certainly could backwards FOIL. There's another thing I could do, I suppose, because this is perfect square, positive even. This is a perfect square trinomial. I could turn that into a binomial squared, or I could just backwards FOIL. Nothing wrong with seeing trinomial, going to the x and the x, class. Minus, 6 and 6. Again, x minus 6 squared, x minus 6, they're the same answer. It's whatever you see first. What about a 4-term polynomial? We saw these in the homework the other day. What do I do with a 4-term polynomial to factor it? Audrey? Group it. So we're going to look just at the first 2 terms, and what can I factor out of just the first 2 terms, Audrey? An x squared to leave us with x plus 3. And then just in the last 2 terms, Michael. Negative 9, of course, in parentheses then.
X plus 3.
Good. X positive 3. And that's important because now in my 2 terms, I have a common factor, Kendall. X plus 3. And what am I left with if I pull out the x plus 3 common binomial factor? Genesis? I'm sorry? X squared minus 9, but Genesis is realizing, hey, that's a difference of squares, which you'd factor into a sum of difference. So I'm going to keep the x plus 3, but I'm going to split that again now into, and there's our answer there. Questions on factoring. Do quite a bit of that, especially last semester. We've done a little of it here and there this semester. Another thing we've worked on a lot with is with exponents and such. For instance, if I had a negative 7m over a 10n squared, and I wanted to square this fraction. Well, first, sign number letter, right? I've got a negative to an even power, class. What if this had been an odd power? It would stay negative. In the numerator, what do I get when I square a 7m? Careful. 49m squared. And in the bottom, when I square a 10n squared, 100n to the 4th. Because when you raise a power to a power, multiply the exponents. What if I had a negative 5a cubed b to the negative 2nd, and I wanted to raise all of it to the negative 3rd power? Well, what does a negative exponent mean? Reciprocal. So I'm simply going to take the reciprocal and cube it. What is the reciprocal of this? 1 over that, right? 1 over negative 5a cubed b to the negative 2nd. So I'm just going to take the reciprocal, I'm going to cube it. In the top, class, we're cubing a 1. 1, right? In the denominator, I've got a negative to an odd power. Negative. I'm going to slide the negative out front, remember, though. Then 5 cubed. And when you raise a power to a power, so I'm going to end up with a to the 9th, and tentatively, temporarily, b to the negative 6th. But now I've got this negative exponent. What should I do? Move this b to the negative 6th up to the top. So my final answer will have in the numerator a b to the positive 6th. All over still the 125, a to the 9th with the negative out front. Questions on that one? Been a little while since we've done anything with negative exponents, remember that. The alternative, by the way, would have been to start by taking care of the b to the negative 2nd, doing a negative 5a cubed over b squared, then taking the reciprocal, getting negative b squared over 5a cubed, and then cubing. Would have gotten us to the same point. It's just however you want to do it, as long as you take care of all the little negatives in there. What if I have a binomial like a 3r cubed negative 8s, and I want to square it? How do we square a binomial, class? Yeah, square the first, square the last, multiply and double. Let your seats do that while I erase the board. Square the first, 9r to the 6th. Square the last, positive 64s squared. Multiply to get a negative 24, double that to a negative 48. Don't lose the r cubed and the s. How many have this when you square the first? Square the last, multiplied and doubled. Questions? Figured it out now? Memory refreshed?
Oh, I haven't, sorry.
Okay, all right. What if we had an a squared b plus 3, and I was having this whole binomial raised to the 5th power? Huh. Then what would we do? Use Pascal's triangle, right? Binomial raised to a power. This is actually something we've done recently, right? It's just we couldn't teach that until we understood combinations, so we had to wait on that idea for a very long time. But yeah, just Pascal's triangle. So class, I'd start by writing
1, 5, 10, 10, 5, 1.
Now here's the key. What is the first term? A squared b. I'm going to take the whole a squared b and start it off to the 5th power right here. What is a squared b to the 5th power? A to the 10th, b to the 5th. Then the whole thing's to the 4th power. Then cubed. Then squared. Squared. And then to the 1st power. And then it's gone. Then I'm going to go through with the 3, and the 3 starts out gone. Then, so 3, right? 3 to the first is just 3. Then 9, which is 3 squared. Ooh, what'd you say? 27. I thought I heard an 87. 27. Then 81, and then 243. What about the signs? In this case, they're all positive, right? If it would have been a negative there, we would alternate, then we'd always start with an understood positive. So then we go negative, positive, negative, and so forth. And then we just got to simplify. What's our simplified answer going to be here? Oh, the Genesis. May need a calculator for some of the later ones, but I think early on we've got it.
1, a to the 10, b to the 5th, plus 15, a to a, b to the 4th, plus 98, x, b to the 5th, plus 270, b to the 4th, b squared, plus 405, a squared, b, plus 250.
Any questions on raising to powers? I feel like we've got raising to powers down pretty well. Another big thing we worked on this year was working with radicals, and that's something that will have to carry over into your future math classes, whether it be geometry or pre-calculus. We need to be pretty good with our radicals. For instance, if we had something like the cube root of a 40, x to the 7th, y to the 6th, we'd have to be able to simplify that expression. Now, we can't take the cube root of 40, right? But I could factor the 40 into 8 times 5, right? Now, not 4 and 10, though that might be your initial thought, but for a square root, 4 and 10 works great. Here we're going to need the 8 and the 5 because we need something I can take the cube root of. We take the cube root of the 8, 2, and I'm going to leave the cube root of the 5, remember. And then we say, well, let's see, how many times does 3 go into 7. Answer?
X squared.
Twice. But
X is 7.
there's still 1 left over. 3 goes into 6. Twice with none left over. Do we remember doing this? Okay. What if we had the square root of a fraction? I said you can't do that. You can't have a fraction in a radicand. You have to take the root of the denominator. But you can't take the square root of 12. So I said we're going to make an equivalent fraction. Instead of a 12 in the bottom class, maybe a 36 or even a 144, but I like 36 way better. We would simply multiply top and bottom class by 3. So we end up with 1536. It's the same thing as 5/12 to remember, but now I can take the root of the denominator, class. 6. Can I do anything with the square root of the 15? So, just leave the square root of 15. The key was to take the root of the denominator. We said if I wanted to add radicals together, they had to be similar. Same index, same radicand. Well, these have the same index. They ain't got the same radicand, though. What do I do to get same index, same radicand? Reduce them down, right? What should I do with the 32? Or maybe the 18. The 18 seems easier. Maybe start there. Yeah, let's factor the 18 into a 9 times 2. Take the square root of the, make sure you're working along with me. That gives us a 3, so we get negative 6 times the square root of that 2. So we take the square root of the 9 to get 3. Remember to leave the 2 in the radical, negative 6 square root of 2. Well, since this came out to a square root of 2, probably 32 is 2 times something. 16, we'll take the square root of 16. 4, that gets multiplied by the 5 times the square root of 2. And we subtract now that they're similar. Of 2. All right. Again, if you need to go back, refresh your memory on those. What if I wanted to multiply radicals? Do they have to be similar? But they do have to have the same index. They have to both be square roots or both be cube roots. In this case, they're both square roots. I just multiply. Square root of 12 times square root of 8, class? Square root of 96. And then at the end, we'll reduce this. We'll see, what square is in 96? People checking some numbers on their calculators. What is it? 4 times 24? All right, so we can take the square root of the 4 to get 2 times the square root of 24, but, yeah, I heard it, do it again. 4 times 6, pull out another 2, so our final answer. And remember when reducing, we'll want to make sure we continue reducing all the way to the end of the problem. Questions on radicals? All right, I've got a homework handout for you to complete. It'll give you review over the equations that are similar to equations you'll see on the test tomorrow. You'll also have an equation, a linear equation to graph using slope-intercept form. I go over this in the next lesson. Now, the next lesson is a pre-recorded lesson in which I go over this material, work these through, go over it, and this should get you ready for any and all equations that you see on the exam. We just don't have time to do this in class. That sick day we had earlier in the year. So work this after school today. Watch the video once you're done with it. And if you need the link, have parents email me. But it's lesson 176 in the playlist. It's the next list up. If for some reason you lose the handout, there's a link to the handout. That just means you have to print it yourself. But we'll go over that. Then we'll finish our review in lesson 177, exam Thursday, lesson 178. Have a wonderful rest of your day. You are dismissed.